or we continue with our lessons. Some of the class, I think I was able to deal with this introduction, but let's take it together now. You see, we talk of this page rank algorithm. This is an algorithm that you use to try and what rank pages according to how important they are, so that we're able to know that this kind of page is more important than this page. So let's see. Assuming I open my own website, then I name it Gmail's website. Then we have another website too somewhere, which is maybe UNES website. We have another one, KNUST. Let's look at this. This is what can be happening. Let's have another one too for UCC. UCC also have their website. It's possible that I may put a link or a hyperlink on my page so that visitors that visit my page, immediately they click on it, it will take them to your next page. This is what we can see in normal real life. Now let's see. Look at UNE and KNUST. They may also be having some kind of what? Relationship. So definitely, UNE will also put a hyperlink on its page so that students that click on it will take them straight to KNUST page. Those who are on KNUST too, they can also be provided with a link. When you click on it, it takes you back to what? UNE. So this thing can be happening between them. But remember, UNE did not have a mutual relationship with me like it is happening with KNUST. This is where the trick is. Then when we come to UCC too will be linking to KNUST at the same time. KNUST linking to what? UCC. If you want to compare this web page and KNUST, it tells you that this one is obviously more important than this page. That is why we say that always, before you'll be able to determine whether a page is more important, then we look at the number of important pages that are linked to it. That is where we see the importance. So definitely you see that this web page here is important than this. Simple. So in this note, this one is just an understanding in the basics. But then let's take it to graph theory or graph theory. We are going to represent this idea in the form of graph. So we have nodes. We have 3 nodes like this. Like this. Then we have maybe another node like this. So this is what is going to happen. I can have this connected to this like this, but then we say that the websites are going to be represented by nodes. Then the hyperlinks will be represented by edges. So these are nodes, while these are what? Edges. So if I have my website here, I have UNE, I have KNUST, and I have UCC. Let me use C for that. So at the end of the day, you see that this one is linked to those. We have a mutual relationship. This one links to this, then we have this one to link to that. So that is it over here. I can also link myself to maybe KNUST. We can also have that. So in the graph theory, you may have it in this format. So that is it for now. So let's look at a particular example that is very, very examinable. So we are going to take an example of a graph, which will be depicting something like this. Then we see how to analyze such a website using our PageRank algorithm. So let's see. For example, I have a website here. I have a website. We have this, and we have that. So let's label them. If I have A, B, C, D, let me put B here. Then I have E here. I think I can have let me just use the real example that I'm using. So we have F here. We have E here. So let's see. If I have A linking to C and C linking back to this, we have this, we have this, we have that, and we have something like this. Now when you look at them, you can see that some of the pages are very important. Example, when I take a page like, if I take a page like E is important over here because C and B are all linking to that. But I can see that it is not linking to other pages. So there are some two things that might happen, and we are going to look at them. So it's possible that when you get here, you cannot go back to any of these websites until the user tries to type something else and leave the page. I don't know whether you are getting what I'm saying. When you are online and you are browsing, it's possible that when I'm on this page, I click, it takes me here. Or if I'm here, I can click something, it takes me there. Then I click on this one too, it takes me somewhere. So at the end of the day, you see that you'll be working or you'll be surfing around some kind of web pages. But then you can also make your mind that, oh, let me just go outside and click something in a different tab altogether, so that it takes you out of it. So there are some, what I just want to show you is that there are some web pages when you get there, it will be difficult for you to come back to the combination of networks that you are working around. But some of them, to immediately you are caught there, it will be difficult for you to also leave that kind of stage or that kind of combinations that you are dealing with. You cannot leave this place and go to a different place. So it's two things that can happen over here. Now let's look at our mathematical analysis here. First of all, let me look at how the arrows are being linked. I have A can link to something, A can also link to another thing, because we see that from A I can jump to B, from A I can also jump to C. So these are the only edges that connect A to other nodes. Now let's look at our B. B links to 1, 2, 3. So B will link to something, B will link to another one, and B will link to what? Another node. Now let's look at our C. C will also link to something here and also links to something here. So let's put all of them down. So let's look at the nodes that are going to link these kind of primary nodes that we have listed. So if I'm here, I can go to B and I can also go to C. Let's look at the B. If I'm on B, I can go to D, I can go to E, and I can go to what? F. What if I'm on C? From C, I can go to A, and I can go to E. So from C, I can go to A, and I can go to E. Now there is something we have to look at. We are going to talk of probability over here. If from A, I can go to two different places, then it tells me that if I want to move to B, then the probability is 1/2, because from A, I can go to two nodes. So if I'm going to C2, it is also a probability of what? 1/2. Why? Because we are dividing it. The probability that I'll go to this guy is 1 over what? The total. Now, when we look at this, you see that it is what? 3 nodes that are connected to B. So it tells you that if I want to move to D, it will also be 1/3. This one will be 1/3, and this one will also be what? 1/3. The same thing applies to this, which is half here and what? And half here. So let's see how we can proceed with this. Pause.